We published a study in 2014. Two groups varied load schemes, and other two groups varied exercise selection. Volume was way higher for the group that chose, but their perceptual about exertion was lower.
What's actually happening in an aging muscle?
You are losing quality. You are losing contractile tissue, but on average, 2.5% muscle loss per year. In order to grow, protein synthesis must outweigh breakdown. Good quality protein profile, meal and resistance training, those are the best ways to increase protein synthesis. The peer review process can completely change the outcome or interpretation for a study. You gotta be the expert and know everything that affects that measurement.
I'm curious what beliefs you've let go of over the last 5 to 10 years.
We still believing that small tweaks, adjustment, the training gonna unleash magical gains. I think optimal is something way broader than once we thought. Every study, when it's well done, is one more tool in the box that gives you one more option.
So, you know, there's a whole community on the internet right now saying that one set is the best. And if you say anything else, you're a terrible person.
Another low volume coat, another high volume coat, you can experience substantial muscle hypertrophy with
So you're considered one of the world experts in hypertrophy. So it's an absolute pleasure and an honor to have you on for the first time. We've known each other for 10 years.
For 10 years,
10 years, yeah. Some good stories shared before you hit record.
Yeah.
But you've come so far, as I said, over the last few days. I've really been going through all of your research for the last, so it seems like more than 10 years. And you had a unique story saying you started at the University of Tampa teaching one class around, what was the class?
Was exercise, nutrition, exercise, nutrition, laboratory techniques.
Laboratory techniques. Yes. So like ultimately how to understand DEXA, how to read a DEXA scan, how to read a
ultrasound, force plate, MET card, linear position transducer, like tracking barbell velocity, how to plug those data from barbell velocity to estimate maximal strength. Like something if you're gonna do a 1 rep max test, it takes too long, especially like in professional practical settings now, like you do like a few sets with some progression for someone's body weight. So you plug those numbers, velocity and the load, you plug in the numbers into a regression line and you get someone's strength. So it was about teaching students like the things we measure in our field, how can you use them in the reliable way, precisely, and what they're good for, the usage for different scenarios and settings. Yeah, it was pretty. The course has a special place in my heart because it was the first one I started here at UT, University of Tampa. So yeah, and here I am 11 years later.
Yeah, one of the challenges that I experienced with the limited amount of time I spent in the lab back in, what was that, 2012 through 14, give or take, was observing how many confounding variables existed in every research study. You're like, wow. So, you get this world of, Instagram influencers who cherry pick a study and then throw it out on social media and go, well, it means this, and everyone has trained this way. And you're like, man, having spent the really small amount of time in a lab that I did compared to you, I was like, I just see the infinite number of confounding variables that almost can't be accounted for. But I love the fact that someone like you is leading the lab, because at least it gives me peace of mind knowing there's someone out there who's thinking about all the same crap that I see. And I'm like, man, but there's this and there's this and there's this and there's this. So the fact that you're the one leading those research studies gives me more faith in the research coming out of the University of Tampa. Yeah, your knowledge is so vast. It's, most, we spoke of this before, most guys are very narrow and they're very good at what they're very good at, but they're not seeing all the forest for the trees. So it's awesome to hear that, like, you've been doing this for longer than most of these guys have been alive.
Yes, man. The first paper I published was 2007, but those confounding variables.
So it's funny to think that your students this year are probably born in 2007.
Yeah, that started to happen. Like when they need to enter demographics for data in the lab, like they are doing something in the lab, and then they go like, "Oh my, I graduate when I was graduating." It's interesting. When we deal with confounding variables, that's very interesting topic. And again, I was telling you, right? I had two great mentors, and one of them always told me, So dealing for research design and confounding variables is the same thing that you are camping in the cold night and you are dealing with a short blanket. And you got to figure out what's going to be left out or what's going to be covered
That's
up.
a really good metaphor.
And usually what is left out is that confounding variable that has no meaningful impact in
Right.
your measurement.
Right.
So it all depends, like what you are measuring. So some confounding variables, they overlap. But if I'm measuring DEXA or ultrasound, a few things are quite different, right? If I measure maximum strength or counter movement jump power, so the things I need to control is a little different. So it's always about, and again, I was fortunate to be exposed to so many, like a hypertrophy. I work with MRI. I've worked with biopsies, analyzing individual muscle fibers. Then worked with MRI, doing like a cross-sectional, whole muscle cross-sectional area, ultrasound, DEXA. And again, DEXA is a measurement for muscle mass. In fact, DEXA measure fat-free mass, right? Everything that's not a fat, DEXA cannot measure muscle mass. Is part of the fat-free mass analysis. So being able to or be exposed to so many different assessments, you gotta learn like, okay, that's what I tell students, like every time you pick a test, right, you're gonna measure, you gotta be the expert and know everything that affects, for good and for bad, that measurement. Then you know what to control. So that's is always about, okay, what can mess up my measurement here? And then, like, again, that varies depending on the assessment you are doing. And then you know what to control. Like, it's interesting what you said, because so many people, like, they never measure anything in the lab. And no, everything they measure is edema, it's not hypertrophy. Or no, that's the most reliable. And I have been measuring those things for almost 2 decades now, right? Like, we know. And of course, every measurement has limitations. It is up to the expert to control. And when you're going to present and publish, be very clear that what was controlled and what was not controlled. I think that's is something really important when you are measuring. I love I like to say I'm measurement arrow freak. So
that's great.
We bought new, like I said, we bought new DEXA. We're going to do a study to figure out how consistent is the new DEXA at this point.
Right.
Because the older one, I knew the consistency, the reliability. This one, now I need to determine again because it's a new piece of equipment. For me, it's always about the measurement arrow, especially last studies we have been doing more with a trained people, and the things don't change that much. Right? Like I measure muscle size in untrained people, I have a 2-digit change, right? Like the muscle size change about 12-15%. I measure the same muscle thickness, right? The muscle size in trained individuals, I'm dealing with 5 to 8%. So I gotta be good at measuring it because the outcome, right, is not that big, it's small. So my noise gotta be smaller than the outcome.
Right.
So that's that's pretty cool.
So what is the most accurate measure of hypertrophy now? You say there's all these different testing mechanisms.
Yes. So it's still muscle cross-sectional area done through MRI. So that's still the gold standard.
Do you guys have an MRI in the lab?
No, we don't. And that's something really interesting to discuss. It's so costly and expensive.
Yeah, it's crazy.
Again, I think 90% of studies in our field don't use the gold standard because, again, MRI is so expensive. So MRI is still the gold standard. You might have a reason for that. We keep telling, because it's so, to outline the resolution for the image is perfect. Like it's crystal clear. I can easily outline and separate each muscle head. If I look at the quads, I have 4 muscles in that group. I can easily outline each one. So that's a gold standard. Of course, it does not differentiate something people now are pointing out and criticizing. Oh, MRI cannot differentiate actual muscle mass, like a contractile protein accretion from edema. But again, it all depends on we call like MRI has a T1 approach or T2. Like a T1 is usually used more for muscle size analysis because it's all about how that magnetic field hit the hydrogen inside your body and how they come back to the place there was before. And MRI kind of uses that image, that information to give us the image pretty much. So if I go T2, like for example, for T1, muscle is pretty dark, and everything that would be fluid would be dark as well. In T2, the image would be brighter, right? Like the fluid, I would be an image that's brighter if I had a more edema or fluid accumulation inside the muscle. So again, MRI is the gold standard, and easily 90% of the studies in our field don't use the gold standard. So, however, I was one of researchers. We have a Martino Franchi from Italy. We have other researchers, that includes me as well, that we validated techniques with ultrasound. So using ultrasound and showing ultrasound muscle analysis comparison with MRI, and that we can precisely measure muscle size with ultrasound. So ultrasound is way cheaper, still not that accessible because a good device sometimes vary from 50 to 60K, right? But we do have studies showing that, yes, ultrasound is valid and reliable to measure muscle size. So again, compared to MRI. And just one example, we published a study in 2014. The study become quite popular now. And I always said that I still don't know the reviewer, but when you submit it, we had 4 groups. Basically, 2 groups varied load schemes, and other 2 groups varied exercise selection. So the criterion group only performed squat for 12 weeks, and then you have other 2 groups that were varying exercise selection. When you submitted the study, we submitted with the whole quadriceps cross-sectional area. So you outline the whole quadriceps only. So then the reviewer got back to us like, come on, guys. Literally, he said that like, come on, guys. You have the gold standard measurement. It would be so helpful for the field analyzing each muscle from the quads individually. Our first reaction was like, man, that's going to be a lot of work, right? Like 50 whatever subjects, pre and post measurement, like analyze each muscle. Right. We did, and that was one of the first studies to show when you varied exercise. So one of the first to show like, squats not that good for rectus femoris hypertrophy. We all know that. Right. Other studies pretty much confirmed. But the 2 groups that varied the exercise selection were the only 2 groups that significantly increased all the individual muscle heads. And I was like, man, we got to give merit where it is due. I don't know the reviewer, but we would say that, you see how sometimes the type of analysis, the peer reviewing process can completely change the outcome or interpretation for a study.
Sure.
That study would show that when the whole muscle is analyzed, it doesn't matter load scheme or exercise selection. Load scheme, at this point, we know, right? Hypertrophy, the way you slice it, but exercise that targets, different exercises that target the same muscle, they induce what we call regional hypertrophy. And we are one of the first to show that, yes, varying exercise was better than only doing one exercise. Thanks to reviewer.
That's great.
He requested, okay, let's do it.
That's a big shift for sure, because that could have changed the trajectory of a lot of things to be able to see that. And that's obviously been reinforced throughout for the last 10 years.
Yeah, that was very, very interesting. But again, like it is, even when you measure muscle fiber cross-sectional area, if you just outline the fiber, you can't separate. You can separate like a contractile protein from fluid in the
Sure.
muscle or edema. So the point is like, and usually because again, the people with the edema stuff, like we don't know sometimes if they're talking about muscle damage or now sarcoplasmic hypertrophy.
Right.
And you got to point it out that if you think about the muscle as a house, right? We have three residents that really need space inside the house. Myofibrillar resident, roughly 80%, right, is contractile protein. And then the 20% remaining, you talk about sarcoplasmic structures. We talk about energy storage, like roughly intramuscular fat, glycogen, only 5% of the muscle volume. So the primary hypertrophy always going to be myofibrillar,
Right.
because that's roughly 80% of the muscle. So yes, MRI can't. Again, if you combine T1 with a T2, but even ultrasound was a famous paper from the Brazilian group. Was Carlos, my mentor, was the mentor in that paper too, from Demas. So they measure hypertrophy baseline, they measure hypertrophy 3 weeks later, and then they measure hypertrophy 10 weeks later. And what they found was the brightness of everything that is edema. In that case, they refer to edema as a muscle damage. Everything that's edema in the imaging for muscle size looks brighter. And then ultrasound, we can do something we call echo intensity. So the image gets brighter in response to exercise. That's probably edema. And then we can also use echo intensity to talk about muscle quality. Now, when the echo intensity is smaller, the image is darker because, again, everything that's muscle tissue looks pretty darker.
Right.
Ultrasound, MRI. And what they found was that 3 weeks, what they measure when they measure 3 weeks after the beginning of the study, don't recall how many workouts they had after 3 weeks. The image was very bright, so they maybe we cannot call that hypertrophy as hypertrophy because the brightness is indicating some muscle damage. But that subsides as you keep progressing and working out. And then when they measure with 10 weeks later, they didn't find any indicator or echo intensity number that was indicating some edema. So again, all those the little details when it comes to measuring size, we gotta be aware and figure out what you're gonna control.
Yeah. So I don't want to assume that the listeners super familiar with myofibrillar and sarcoplasmic hypertrophy. If you could maybe help explain that a little bit, help understand it, and then differentiating, maybe getting into how we would train to specifically train. If we can isolate one more than the other, I'd love to know what you know about that.
So again, when you're referring to myofibrillar hypertrophy, usually talk about the addition of sarcomeres in parallel, right? We are talking about adding contractile protein. And again, the muscle is 80% myofibrillar content. So as think about that, I think a good knowledge is like think about the whole muscle as a spaghetti package.
Yeah.
Each spaghetti is one fiber. Inside that fiber, 80% is contractile protein. Each fiber individually is growing in cross-sectional area. The whole muscle, the whole package expands as well. So again, when you measure muscle cross-sectional area through MRI, there's a byproduct of each individual muscle fiber getting bigger, right? And that's we measure cross-sectional area. So, and then you have the area that is dedicated to other cellular structures, energy storage, and then that area also grows and expands. That's the sarcoplasmic hypertrophy. So sarcoplasmic hypertrophy, and again, Mike Roberts from Auburn, he has doing great research there. I think you are way past to call sarcoplasmic hypertrophy as a unicorn. It's something that, yes, it happens. Measurement's a little tricky. We still advancing our understanding about what is the contribution of sarcoplasmic hypertrophy to the whole hypertrophy process. Because again, we're still dealing with the smallest proportion of the fiber or muscle size. So again, myofibrillar is the actual addition of contractile proteins. And then I was saying I didn't finish like the again the other two residents. We talk about sarcoplasmic reticulum, where the muscle stores calcium for contraction, and mitochondria. So again, sarcoplasmic reticulum, mitochondria, the space dedicated to energy, intramuscular fat, glycogen. That's the sarcoplasmic space that also grows.
So for sarcoplasmic hypertrophy, the really only one we can influence is energy storage capacity, like glycogen.
That's one of the things that would influence sarcoplasmic hypertrophy, probably changing the glycogen levels. But again, you got to think about combined glycogen and intramuscular fat corresponds about 5% of the total muscle volume.
Right.
So how much that would be
minimal,
important, or we will be able to notice is something we don't know yet. But again, we know the muscle, not just the space dedicated to contractile proteins, the other space, a more liquid gelatin environment, also grows a little bit as well. That expansion of the space that's not dedicated to contractile protein is what we call sarcoplasmic hypertrophy. At this point, and that was interesting, that was kind of a very old belief or hypothesis that certain training types would be more sarcoplasmic hypertrophy dominant and other training types more myofibrillar. At this point, we are very, again, we need more data, but we don't have a data to say that training regimen A emphasizes primarily myofibrillar and training regimen B emphasizes primary sarcoplasmic. We don't have any solid data to actually we can do something more here about sarcoplasmic when you train like this compared to other training regimens. We don't have a data to strong evidence to support that claim. Okay?
Understood.
So yeah.
So speaking of sarcomeres in parallel versus sarcomeres in series is an interesting thing I think most people wouldn't understand. I'd love to explain what you know about that within obviously kind of context of what we're talking about. So, when we're training for general hypertrophy, we're adding more sarcomeres in parallel.
Yes, but you're also adding series too. But yeah, go ahead.
But up to a point, right?
Yes.
There's a certain point where it seems to no longer continue. Yeah, I'd love to have you explain.
And I think sometimes people get a little confused because that tells my muscle is growing, right, in length. Because again, guys, muscle is a 3D structure, right? We have the width. So when you measure cross-sectional area, we are accounting for the 2 dimensions. So cross-sectional area measurement always comes as a centimeter squared, right? The number 2 indicating the width and the height of the muscle. So the change in that dimension and this one accounts for change in cross-sectional area. So in the measured thickness, a lot of studies I do in my lab, I'm measuring the thickness of the quads. So from the top of the bone all the way to the superficial, the superficial ponerosis of the muscle. So thickness is just one dimension, right? Just the change in this plane. If you have a cross sections of the muscle along the muscle length, you can also estimate the muscle volume, and muscle volume comes in centimeter cubic. So you got to think that most of our muscles, they are like pinnate muscles, right? So that means the line of pull, your tendons right here, and they run angle, right? I think if I do this, if I do this better. So the line of pull, the tendon is here, the fibers run angle. So you got to think that when the muscle is growing this direction, now you got to add sarcomeres in series because the muscle is attached here, the fascicle is attached here.
Right.
But now it got to go longer because the muscle grew in that direction.
Right.
So again, there is functional reason to add sarcomeres in series because muscle grows also in length. And most of our muscles are pinnate muscles. The fascicle length increases with the training. So few things we know, usually training people that have a longer fascicles because the thickness, muscle is thicker. So they have a longer fascicles and also the penatial angle. Again, that's the tendon, that's the fascicle. When you are more and more trained, the muscle, the angle gets cheaper.
Yep,
so
makes sense.
again, so that's why we also add. I think most of hypertrophy is still about parallel hypertrophy or adding sarcomeres in parallel. But we know why the muscle also grows in length, especially for pinnate muscles, right? Because now it was here, it's thicker, the angle gets cheaper, you gotta go even longer now. So that's what happens with a training.
As you speak about that, one of the things that's coming up is the conversation between trained and untrained individuals. And as a guy who's now 44, one of the things I'm most interested in is maintaining the tissue quality as I age. I've obviously put my body through a lot.
Mhm.
I wonder if you could speak a little bit to like what's actually happening in an aging muscle that changes the property of the muscle, say from someone who's 19 as compared to someone who's 49. Like, is there a calcification going on? Is there thickening of the soft tissues? Is there like shortening of the contractile fibers? Like, what are all those things that are happening in an aging muscle versus a young muscle?
There are several things taking place. I think maybe one of the most remarkable adaptations with aging, and I joke with my students all the time, after 30, join my club. Let's lose muscle together. Of course, it's going to be a curve all the way downhill or more flat. It depends what you do with exercise, nutrition, so on and so forth. So inside the muscle, because think about that, what gives the fiber shape and function pretty much is the nerve, right? To have a different motor units under one motor unit, only one type of muscle fiber. So again, there are adaptations at central nervous system that the neural drive also start to decrease to the muscles. That also leads to another or several events that take place inside the muscle. But simply put, I think the way that everybody can grasp it is that I was referring to echo intensity. So there is an increasing no contractile tissue, fibrous tissue inside the muscle. I can send you later. I think it was we have when you look at MRI from younger muscle versus older one. Like I said, everything that's muscle contractile tissue is pretty dark. So the image. So when you see MRI or ultrasound from someone who is older, you see like the image is quite bright because again there is an increase. We are losing quality. We are losing contractile tissue, and you're adding more fibrous tissue, more things that actually don't help with contraction and force production. So yes, so bottom line, like the simple way to put it is neural drive to the muscle is decreasing. Your ability to recruit the muscles
is that
changed.
Because of training, like less physical activity? Could you offset that?
Oh yeah, for sure, 100%. And again, we all know that I always tell people like aiming for the strength and the rest will follow.
Yeah.
Like hypertrophy will follow, power. So especially for older, when it comes to the best predictor of functionality is rate of power development. Yeah. So how rate of force development, how quick you can produce force. That's power.
Yeah.
So that's the best predictor of functionality in older. So we do have a data from swimming and triathlon masters association showing that resistance training is the best intervention, and that's why it has been widely used as a therapeutic intervention for older individuals in so many different scenarios. But data from senior triathletes and swimmers compared to their sedentary peers, they have a more muscle, they have a more fat-free mass tissue. So it goes like, think about that. By 80s, if you never exercised and you got lucky to live until 80, on average, you might lose 2.5%. After 30, especially it gets like it accelerates a little bit more after 40, but on average, 2.5% muscle loss per year. Whereas when you see people more active, that can be 5 times less, 0.5%. So yeah, definitely exercise can slow down. Of course, nutrition plays such an important role as well. But being active is a good way to maintain muscle functionality. I think that there will be a moment that just doing cardio, and you do have a data on that, that I think I forgot was middle-aged people, and what they saw that when people were doing cardio, the muscles involved were maintained, but the muscles that were not involved in the cardio, they lost. They decrease in size and they decrease their mass. So again, yes, definitely physical activity is the closest thing we have to we call like the youth font of youth, like you can live longer. Is exercising for sure, especially from a muscle standpoint, right? Because what allows you to move and be functional.
Sure. Yeah. What do we know about deterioration? This is maybe off topic, but what do we know about deterioration of stem cell and satellite cells in muscles as we age? So, for example, my specific question is sort of selfish. At 44, because of what I put my body through, how hard I push my muscles, how hard I push my body, people are telling me that I should expect less progress now than someone who maybe up to 44 hadn't really trained very much, hadn't really put their body through very much. They have a greater capacity to build muscle now. Whereas, I've got pretty good muscle memory. I've got great psychological ability to push my body. It's been suggested to me that because of what I put my body through, I won't be able to push my body as hard as someone who's maybe got these fresh muscles that have a lot of prevalence of stem cells and satellite cells and whatever mechanism exists there. I don't know, but I'm just sort of asking the question, like, what would be the difference between someone who's pushed really hard and someone who hasn't?
I think, I don't know if I would agree with this idea. I think that the reason, right, the classic diminishing returns, like you are close to your ceiling compared to someone who never exercised.
Right.
You still able, again, because think about that, when we talk about satellite cells, is the stem cells we have in the muscles.
Yeah.
And usually because the muscle has something interesting we call myonuclear domain. So in the muscle, it kind of there's a very specific characteristic of muscle size, right? The number of, we have several nuclei inside. And again, they're important because they send the genetic code for protein synthesis, right? We always talk about that. In order to grow, protein synthesis must outweigh breakdown because that protein turnover, right? 24/7, you are breaking down and building protein. Kind of have a new biceps inside your arm in 70 days, something like that, okay? So that protein turnover keeps going on and on like a 24/7. So to grow, muscle protein synthesis must outweigh breakdown. So, and protein synthesis from a biological standpoint is messenger RNA translation. So we get the gene code in the DNA, right? We send out to the sarcoplasm, and then we have structures that are gonna read, and all the structures that bring the amino acids and build the protein. So again, so usually satellite cells, so every time you have a damage, something that activates satellite cells, usually they migrate to inside the muscle, and one of key characteristics or function of satellite cells is donating myonuclei.
Okay, right.
So now maybe where this person is coming from, that you have probably more myonuclei because your muscles are bigger. But again, I think the main reason is because you're probably close to the ceiling effect. Because someone naive or untrained has more potential because again, like whatever they do, they're gonna grow a lot. But don't think that capacity about adding satellite cells or satellite cells donating myonuclei would be so different.
Got it.
It's different because the training history, right? But I don't think that.
Do you run out, or is there a limited capacity of these myonuclei?
For what?
So let's say, well, because I've been training for so long, is there a finite amount? And once I've used them all, there's no more, or will your body keep producing more?
No, they're still there. Because again, like think about that. You still, the muscle is still repairing, remodeling. They play they play such important role when it comes to that process about repairing, remodeling.
Right.
They are there. But again, as we each nucleus kind of control certain area of the muscle, that's what you call like the myonuclear domain, right? Because there is certain space. Again, a lot of discussion about this. We're still assuming that's how the muscle operates. Certain nuclei, they control certain areas. As the muscle grow, you gotta add more nuclei to maintain the myonuclear domain.
Right.
I think what makes that a little reduced is because now you have a bigger muscle,
Sure.
but don't see probably aging and other things associated with the aging process kind of decreases a little bit that capacity, but it's still able to do that. That's why like even older people, once they start resistance training, they grow muscle as well.
Right. Yeah.
Although if they have the anabolic resistance, they're still able to grow muscle.
What's that? What's anabolic resistance?
It's at same load. If they have like 3x10 older compared to younger, usually the response, like if you see the response for protein synthesis is similar, but the magnitude is different. So younger, they have a greater rates of protein synthesis.
What do we know why? Is that a hormonal thing, or do we know mechanisms?
That's something that's pretty much not my field of study. Why? But that's kind of what we see in studies with older people, like especially those that compared with younger people. Cool thing, like some studies suggesting that maybe more volume can kind of overcome the anabolic resistance. So interesting studies from group of friends of mine comparing 1 versus 3 sets with older and better results. But yeah, there is certain thing we call anabolic resistance, but more from a protein synthesis standpoint.
Got it.
Not from a cellulite cell.
Yeah. So you mentioned balancing, or I guess it's balancing anabolism and catabolism. Like we have to be in this anabolic state. I'd love to explore that because there's obviously things that lead to anabolism, things that contribute to anabolism. We know that certain exercise is going to induce, greater anabolism for certain amounts of time. So let's just explore that entire realm. So you and I just finished a workout. What's going on inside the muscle?
Yeah. So again, that's a very good question. So it's always the balance, right, between anabolism and catabolism. And they work very closely together. So after workout, we see the association between protein synthesis and protein breaking down. When you talk about association between variables, we use a coefficient of correlation we call Pearson. Close to 1, we like to say that's perfect association between those two variables. And the association between protein breaking down and protein synthesis after workout is above 0.90.
Wow.
So again,
they're both happening.
Both, yeah, because you're increasing protein turnover.
Would it happen in different places, or like they're both happening within one muscle or different parts of the body?
In the muscle, that is being working out. Yes. So again, overall, is all about the net protein balance throughout the 24 hours. The difference between synthesis and breakdown gotta be positive.
Net for 24 hours.
Then you're gonna, yes. So that means you are adding muscle. So again, after workout, both increase because again, the protein turnover is still there. So what are good ways to increase protein turnover or protein synthesis? High protein, good, like a meal, right? Like a good quality protein profile, a meal, and resistance training. Those are the best ways to increase protein synthesis.
Well, there's some nuance within that. So if they're both being turned on within a workout, I would suspect that the amount of work you do would influence which one's going to be turned on more, right? This is probably getting into the volume conversation, which is a little bit more your experience. So like if I'm doing a low volume workout, high intensity, is that more likely to induce more anabolism and less catabolism? Or if I'm doing higher volume, low intensity, like are they going to, the volume and intensity going to impact the magnitude of anabolism and catabolism within a muscle?
Yeah, probably does. That we don't have too many studies. The studies we have is like comparing 1 versus 3 sets, or 4 versus 3 sets, or like 1 versus 3 sets, or 5 versus 3 and 1. And
which one got the best result?
So the multiple sets
5 was better than
Yes,
1?
yes, better than 1 for sure. Yes, better than 1.
So, there's a whole community on the internet right now
Yeah.
saying that 1 set is the best. And if you say anything
No, I
else,
think
you're a terrible person, Eduardo.
no, I think you gotta think that the consensus we have with a training volume and I'm not the low volume coach, I'm not the high volume coach,
Right.
but I think we researchers, the consensus we have at this point, you can grow substantial muscle, right? You can experience substantial muscle hypertrophy with a low volumes. So we're not saying
What's considered low?
low is below if you go by one systematic review, they separate as all the way to 12 is low
Per week or per workout?
per week, right? So talk about 2 workouts, 6
Yeah.
sets per. So 12 weekly sets low, 12 to 20 moderate, and then weekly sets above 20 high volume. So again, I think that's something, maybe one of the few things we all agree, because some people think that high volume does better, right? Like if you only squeeze that gains, if you want to max out your gains, you gotta go super high volume. After studying that for a while and see how people respond very different to same training, like I have one group with a 12 weekly sets, another one with a 18, and the third one with a 24, the way they respond is completely different, although they are undergoing the same volume. I like to say,
So within each cohort, they're responding differently?
yeah, they respond we have an average, but that's how I don't know when they started, but probably the last 6 or 7 years, every time I publish, I like to show individual responses because we report data on average basis,
which is not always accurate.
But yeah, we see each line represents one individual.
So talk about that. I want what is the variance you would see within a group of doing 12 sets a week? Like how much?
Oh man, you gotta see some. It's crazy. For example, think about that. For my PhD, I used MRI, and also the masters. I also the 2 projects I used MRI. So the average was 12. We'll talk about untrained people. The average was 12% muscle cross-sectional area increase. The range was 0.7 to 23%.
Oh my gosh.
So again, and you see that consistently. So there's another discussion in the field, how optimize designs to actually study individual responses. The phenomenon is there. And I think we all know that, right? People respond different to medication, to diet. We all know that. I think we need to advance in the way we are studying individual responses. That's something a lot of people agree. But from a practical standpoint, sometimes I know it doesn't sound too sexy, but you got to be your own lab. It's try and error. Totally. You got to figure it out. I think a good start, low volume can be a good start for you. If you want to go higher volume, is that doable for every muscle group? Probably not. If you want to hit every muscle 20, if you're not professional, living from lifting weights and be a physique athlete, how are you going to find time to hit 20 weekly sets or training twice a week, 10 sets per muscle per workout? So it's a lot, right? It requires a lot of time. So a lot of people also, when it comes to high volume, it can be like a specialization phase for certain muscle groups you want to emphasize. You try something different. Give a try. I'm always saying that. You try so many different things. Give a try to high volume. Because my opinion as a researcher is we are dealing for such small differences that maybe for 1% of population, those differences really matter. But for so many a general individuals or general population clients, maybe that additional gain with way more volume might not be practical relevant from a practical standpoint.
Right.
So again, I think at this point, my staging when it comes to volume is you can grow substantial muscle size, you can experience substantial muscle hypertrophy with a huge variety of volume. I would say that if you're doing 5 weekly sets, maybe you should do a little more. But I think that's something we all agree. After 10, after 20, after 30, the uncertainty also increases big time as well. And after, in my opinion, based on the way I see the data, after 25 weekly sets per muscle group, those differences start to be comparable to measurement error. I don't know for who that would be relevant. But again, I just don't want to pass the message that there is only, I think that's something you got to do better. It's not one certain way that grows muscle. It's not one specific training volume. And even the training volume literature, we don't have a good evidence about how your exercise selection impacts training volume. What about the frequency distribution? We just had now a few weeks ago, I guess, we had the preprint about now weekly session volume. And I think the number that kept muscle growth was about 11 sets. After that, they yeah. But they also pointed out, again, I haven't read the paper yet, but they also pointed out you can grow substantial muscle with less than 11 sets. So again, I think the message is so divided now, is high or low. There's so many options, there are so many combinations of training volume, exercise selection that they're going to grow muscle as well.
Yeah. So, having looked at genetics for the last couple of years, there's obviously genetic considerations there that, eventually we'll get to the point of if you have this gene, you train this way. If you have this gene, you train this way. I think we're on that track.
Yeah, we're probably going that track, right?
Yeah. Yes. I know for me, having poor inflammatory genes, so I have to support inflammation a lot. I find now if I train too much, I just don't have the ability to recover from it. Whereas when I was competing and taking a bunch of anabolics, it was very different. So I almost compensated for my poor inflammation by taking anabolics. Now without the anabolics, I'm if I overtrain, it takes me so long to recover. What I also notice is I've actually tried some experiments where if I'll do 12 to 15 sets per week average per body part, what I do outside of the gym matters enormously. So if I just get some additional basic movement in, I'm going to the beach, I'm going for a walk, my recovery and my performance maintenance. So if I go Monday, Thursday, chest workout, 2 consecutive weeks or 5 consecutive weeks, and 1 week I don't move, I'm sitting on my butt too much at my desk, and the other week I do move, the difference in my retention and performance or the ascension in performance is significant just by adding in some additional movement. If I'm active, I'm way more effective in the gym. It could be an age thing, but just observationally, there's so many variables. I'm man, how is that playing into a research study? And well, it's probably not. But I understand you guys are taking.
But that's general. That's pretty cool, man. I really like the perspective, and again, that's the beauty of science. We there's so much unknown and so many questions we don't have a good answers. For example, we are running a study, and now I was listening to you talk about that. Man, I should have done something about it for studies with trained people, because now we're doing study about sleeping, and what you told me totally makes sense, but maybe I gotta evaluate that for the next moving forward for the next studies. I can do that. Somehow I'm doing the sleeping study. We started with this, and then I'm gonna go to your point. We started a lot of studies when it comes to sleeping, they artificially manipulated the people's sleeping pattern.
Yeah.
And man, we don't know how long it takes to adapt, so on and so forth. So let's do, and we do have a compelling evidence or interesting evidence that poor sleeping might affect 4 hours of sleeping compared to 8 hours.
Massive.
Big decrease in protein synthesis. People who lost same amount of body weight, those who slept less hours, lost more lean tissue. And then we do have a data that suggests sleeping might be a factor affecting the muscular adaptations. So the study we decided to do, and I love your idea to record in the lab, and then I told you we are wrapping up, that's a study. So the idea of the study is okay, initially we were let's do let's try to separate people we call short sleepers. Those who sleep less than 5 and those who sleep more than 7 would be the normal sleepers. So turned out we are using college students. Students turned out we didn't have as many short sleepers. So now you're doing the second. I hope you get to the point that we can compare short and versus normal sleepers. But we are using the device we call accelerometers, like the Fitbit. They do that, right? Count the step, physical activity outside the study. So the initial question for the sleeping study was, do sleeping patterns affect muscular adaptations, aka muscle size and strength? So, and the secondary question is intra-subject design. So, is the dosage, right? Volume is about the dose or quantity. So, the secondary question was, can training volume mitigate any potential negative effect of poor sleeping? But we also tracking we are tracking sleeping week 1, the middle of study, and the last week of study. And then what you're gonna do is we can use physical activity outside the study as a covariate.
Right.
So I can start to have an idea, like what you said, totally makes sense to me. But I'm not aware. Again, maybe we do have a data. I'm not aware about how physical activity outside the study or outside your training regimen, let's put it that way, impacts your adaptations in the training or performance. Now is college students untrained, because we know a common recommendation for poor sleeping is exercise. So for this study, I'm enjoying, like it's the first study with untrained people in a while. But now what we're gonna do is we can analyze physical activity outside the study,
right,
and see if that's a covariate affecting the things you're measuring.
The next thing that comes up for me as you're saying that is where it may be more impactful versus less impactful. If someone's already aerobically fit, that extra activity may not impact them. If they're anaerobically fit, then it may impact them more, right? Because if they're aerobically fit, they have great recovery to begin with. So there's an interesting. There's so many like you keep going down the Russian doll.
Yeah,
right?
that's very interesting, and something that I notice, especially with untrained people, when they start, they get so excited, they change their lifestyle, and that's why in that study, like, okay, let's see. Let's measure physical activity. So when they for the week you're gonna measure sleeping, we told them, hey, keep the wristband. It's kind of a watch. Keep that on for 7 days, 24 hours.
Yep.
So now we can see like did participate in the study make them more active outside the study? Because I agree for you, maybe for someone who's already very active outside, does that play a role in the
Doesn't make any
study?
difference.
Maybe not, right? Very likely, probably no.
Right.
But what about those who don't move too much? So yeah, maybe we are wrapping up the study in 2 weeks. So we're gonna start probably early fall. We're gonna have some data about that.
So you've been studying research for 18 years, you said, since you kind of published your first study?
Yeah, the first publication was 2007.
Yep. So I'm going to guess you've come a long way in your understanding. And one of the things that we sort of spoke about before I started recording was some people in this space are very attached to their beliefs and they have a very hard time letting go of their beliefs.
Yeah.
I'm curious what beliefs you've let go of over the last 5 to 10 years that you held originally and what those are.
Man, that's the question. I like the question. I gotta say that I think usually people are very attached to beliefs, regardless the space, right?
Yeah, that's true. I'm not just muscle. That's just because that's us.
Yeah. But I don't know, Ben. Like, what put me into this type of research? I started lifting. I was about turning 49, and I started lifting. I was 16.
Wow.
So I was really into like a learning, and again, from 60 to 20, it was like just going to the gym.
Sure.
But maybe I go backwards, because every single volume study, I think at this point we published like from the lab 2, other collaborations we have other 2. We have published a lot about volume. every single study I started about training volume, I always thought more would be better. So that's something I had in my mind, that more is better. And then you start to go back to physiology and some everything physiology. I was talking to a group of people we all researchers, and can you name something for me that has a linear relationship, two variables that have a linear relationship in physiology that never plateaus? No,
No.
they will. Like, why volume will be that, right? So I think I always thought more would be better, and I think that somehow shaped my training lately. Again, now training is more about be able to keep it up with the kids,
Yeah.
be active. Is about that. But yeah, always was when I thought I need to do something better. My approach always was about increasing the dosage, increase the number of exercises or sets, whatever. That's one thing that I changed big time. The rep range, I think we are all there, right? Assuming that there was a certain rep range that was optimal for hypertrophy. Uh, and then maybe other two things that more general. We always, I think a lot of people still have the. I don't want to break any heart, but we still believing that small tweaks, adjustment, the training gonna unleash magical gains. I don't see that anymore. So I don't. That's something that I totally detach from that. I think a lot of people, if I do small tweaks and this and that's gonna unleash magical, massive gains. I don't think that's the case. And the individualization and the optimal thing, that concept about what is optimal, I think it is a little cliche, right? But I think goes back to the three pillars of evidence-based practice. So you have the best evidence. That's something people misunderstand about being evidence-based. It's not get the last paper published and apply that towards yourself or clients, right? You see the body of literature collectively. I keep saying that every study, when it's well done, is one more tool in the box that gives you one more option, right? This is it.
Right.
It's not getting the last study and apply that study methodology or training approach towards clients or yourself. That's not evidence-based practice. So we have the best evidence available, and that's the body of literature. And again, that's why we have a more studies with a high quality, your toolbox gets bigger, you have more options, right? The second thing is your clinical experience, your experience as a trainer, as a coach. And then the third pillar that is the used to be the it's still right the same, the patient, they call the patient, because that was described in medicine field, they call the patient values, but I think is about the patient preferences, and that goes lifestyle, that might drive your choice about exercise selection. Some people do better with exercise A versus B,
Of
those
course.
kind of things.
Yep.
And I think the optimal is something way broader than once we thought it was. I think those are my belief chains.
Yeah, one of your most recent studies, I could be wrong, but wasn't it an autoregulation study where people were self-selecting? Were you doing that?
Yeah, we did that in two. That was the first study I did at UT.
Oh, wow.
But now, do you know, Ben, I would change, because from that, again, from what I understand now about autoregulation is when I try to measure, evaluate your readiness for exercise, right? Like before the workout, or I can also do post-workout through session RPE, see how you are perceiving exertion after, and using that info. So I'm gonna try to get some psychophysiological parameter, performance parameter that helps me with a decision-making process moving forward. That's one thing. That's how I see autoregulation now. What I did in that study, I think was, and something I think coaches and trainers, they gotta do more, is provide people with more options. There's so many cool studies in model learning that people do better when they are provided with options. You see the brain behind the program. Again, the toolbox, right? You know everything that works, but you let the person choose something on a daily basis. I'm very confident that increases adherence.
Right.
When you have a option to decide, you do the things better. So what we did in that study was we had one group with a fixed exercise selection routine, and the other group was able to decide whatever, like 3 times per week training. So the lower, like the lower leg menu, right, was squat, leg press, and knee extension. So if someone wanted to do only knee extension for that week, 3 times per week, fine. We didn't control that. What we found, slight advantage when it comes to fat-free mass accretion. Again, was very slight, but what caught my attention that volume, when you did the tonnage, right, the sets times reps times load, was way higher for the group that chose, but their perceptual exertion was lower.
Oh, wow. That's interesting.
So again, I think that's something that people need to consider more. Like I said, for hypertrophy, there is specificity about hypertrophy. We do know now better things that might be more important to hypertrophy. Now we have a better understanding, but it's still like a lot of options. And you, as the brain, you provide with the options that that's gonna work, right? So yeah, we did that study with I called autoregulation, but was more about giving people autonomy,
Yeah.
letting them decide. The results were very, very interesting. Yeah.
So what I heard was they had the opportunity to pick, therefore they did more total work, but their perceived effort was lower.
Yes.
Do you think where that would express in benefit is over time, because now they're actually accumulating way more work over time?
Yes, that's great. And that's a great question. And one of the problems with our field, I keep saying our field is new, we keep evolving, but overall studies are quite short.
Yeah.
Right?
Very true.
We can't capture more than the time frame you're studying.
Right.
It's hard to make, and that's something I always tell my students, like we can extrapolate generalized findings beyond study duration, population, intervention used, right? So so that was done, not necessarily that's going to be replicated in different scenarios or conditions. So my thought, if that additional work would be a problem, I think people would start auto-regulate exercises that would be less demanding.
Right.
I think they would. I would love to keep going.
Yeah.
But I think especially experienced lifters, right? They, at this point, right? I know, like we know exercise, I feel better, you perform better. I think, and that study was with trained people. They were really strong as well. I think moving forward, if they continue the intervention, I think they would start auto-regulating, choosing exercises that now I need to choose something that's less demanding. It helps me recover better.
I'm right there with you. I was just thinking, like, I would choose an exercise that I can do as much load as possible with the lowest perceived effort. For sure.
Yeah, I think definitely we would auto-regulate the choice for exercising that way. I agree. Yeah.
Yeah, whatever feels easiest. And that would be mechanically dependent, right?
Yeah.
Depending on somebody's.
That was 9-week study. Was huge difference. Like the difference was man, well, I think was 200,000 pounds, was 100,000 kilos difference.
Wow.
In 9 weeks frame.
That's crazy.
Yeah. It's something that surprised me too. And again, is that a population issue? They chose more compound movements.
Huh.
That was something that probably why the volume was higher.
Right.
They chose more compound movements.
What do you think about the effective reps model? Do you think that's a worthwhile model, or do you think it's limited?
At this point, model is something that needs to be validated. And it's always hard when you talk about other people's work. So I do know I have other evidence that would not support the model, right? I think cluster set is a good example because you do, instead of doing 5 reps, you do 2 reps, rest 30 seconds, and do another 3. Or if instead of doing 10 reps straight, you do the same as well. It's like small clusters within a set. In my opinion, like it needs validation. It needs to be. We need experimental design to actually test. I remember, like we had a while ago. We have a hypothesis hypothesis model for interference between cardio and resistance training.
Yeah.
That was from the shared, and I forgot the second was just 2 researchers, but they actually published that, right? We must acknowledge that effect reps model has not been undergone to any peer review. I'm not aware of any peer reviewed paper that they submitted that hypothesis, the model, right? It's still a hypothesis. Then we got to test the model to develop a theory. So a lot of people assume, no, it's not theory because it's not something established. The idea, I would say the idea is totally off. No, but we do have a other side or evidence that, yeah, but you can grow muscle this way, right, as well. So I think what we need for the model is, again, if you like to follow the model, that's fine. But my only concern is when a model for me is something, it needs to be validated. Even the hypothesis has never been submitted to a peer review in which experts in the field can discuss and do the back and forth with the proponents of the model.
Right.
That's one thing we need. After that, we need to put together a study design to evaluate the model. So at this point, like, how I'm gonna say is, again, is others people work, and I think if that works for you, I'm fine for that. I'm not here to say like, no, that's a crap. Don't do it. Don't follow the model to guide your. If you think it's working for you, I'm always about that. Do you think it's working for you? The problem, yeah, go for it. The problem when people start to, oh, we need to explain why it works, and we do that to extrapolation of things that we know, like you can't make the jumping logic or jumping from one study that was designed to evaluate certain thing, and now you want to extrapolate that for outcome for human beings or something like that. It needs to be tested. That's my opinion.
Yeah, I agree. How are you using AI now to accelerate the rate of your learning in your study?
What I use at most is I learned coding for statistical analysis. Again, I was fortunate to have the mentors I had. I said that already. And my mentor always about coding and modeling our own statistical analysis and the pros and cons of that. More pros, right? Like why we do that. So AI really helps me when I'm doing something and I get the error message from the software, and AI is really helpful there. Like it finds the miss. Sometimes it's like you misplace one thing that changes completely the coding. I have been used a lot for statistical analysis to double check when, especially when the things I get error message or run the model and hey, that's what I'm planning to do here. That's the idea. That's the design. But like I said, it's all about the prompts you provide. It's similar to workout, right?
Sure.
We were talking about that. Like you gotta warm up the machine. And that's because I also did things with machine learning. But you gotta warm up the AI. So go little by little. It's all about the precision of the prompts and how we provide AI with information. It's what makes it more helpful. I don't like when they ask straightforward questions about what I should do about statistical. So when they provide the modeling and the code, my perception, I feel, is more helpful. So usually it's more about that, like using AI to help me with statistical analysis. Of course, I use like a teaching sometimes, like to organize assignments, to organize those kind of things, reviewing. I keep, yeah, I don't know, like was wondering one day, like, can we train AI to look more on images for muscle and start to see some patterns? Because I have so many images in the lab, like because again, with the whole, we're gonna publish one study about, it's going to be acute swelling, right? Like sessions with 7 sets, 14 and 20 weekly sets, and 21 sets. So session sets, like 7, 14, and 24. And we measure was before, right after, immediately post, 24, 48, and 72 hours. So, and then I was analyzing some images, like, man, I have so many images here. And like I said, we knowing that things are brighter, we probably be dealing with fluid accumulation, edema, or damage, something like that. So I don't know if someone is doing something about it, but like I would love maybe to play more with AI and get the image from older MRIs we did in the past and start to see some patterns about muscle quality.
I'm sure that's
edema.
coming. We can't be that far
Yeah,
off.
I think so, right? Like, because you can use the baseline as your control, like when people were fresh before the study intervention, we can use that. And hey, that's my baseline, right? What are the traits and patterns you see different when you compare this set of images that were done post-study compared to the baseline,
Right.
and maybe start to, maybe I'm gonna do something about it.
Eduardo, your understanding and knowledge of this is unbelievable, man. I really appreciate you making the time to come over. I don't want to steal your entire day, although I'm sure we could sit here for another 6 hours and hash this stuff
thank
out.
you.
I'd love to continue to learn from you, man. Thank you.
Thanks so much, man.
Pleasure,
Thanks for
brother.
having me.
Thank
Yes.
you.